So, you hear this idea. The universe is a simulation. It sounds like science fiction. It sounds like something from a movie, and maybe it is, but a lot of smart people take it seriously. Philosophers, physicists, tech billionaires, the idea won't go away. The basic thought is simple. Look at how far our own video games and simulations have come. In just a few decades, we went from Pong to virtual reality worlds that can almost trick our senses. Now, project that forward 100 years, 1,000 years, a million years. It seems likely that a civilization advanced enough could create a simulation of a universe. One so detailed that the beings inside it wouldn't know they were simulated. They would have consciousness. They would feel real. They would think they were real. If a civilization can create one such simulation, they can probably create millions or billions. So the argument goes, if it's possible to simulate a universe with conscious beings, then there are probably way more simulated universes than real, base reality universes. Statistically, it's just more likely we're in one of the many simulations than the one original reality. It's a strange thought. It can make you feel small, or maybe it's a relief. It can explain some of the weirdness of the universe. But it leads to a big question, a very human question. If this is a game, can we find the cheat codes? If the universe is a simulation, could we hack it? First, we need to be clear about what hacking means in this context. It's not like in the movies. No one is going to plug a cable into the back of their head and see green code raining down. In reality, if it's a program, is infinitely more complex than any computer system we've ever built. Hacking it wouldn't be about guessing a password. It would be about understanding the system at its most fundamental level. We can think of it in a few different ways. There are different levels of hacking. The first and most basic level would be finding the glitches, the bugs. Every complex piece of software has them. No matter how good the programmers are, something always gets missed. A massive universe-spanning simulation would surely have some. What would a glitch in reality look like? Maybe it's something small and personal. That feeling of deja vu where you're certain you've lived a moment before, is that just a trick of the brain, a misfiring of memory? Or is it the simulation reloading a previous save state, causing a momentary overlap? What about a coincidence so perfect it feels impossible? You think of an old friend you haven't seen in a decade, and they call you a minute later. Is that just random chance in a world of billions of people? Or is it a bug in the code that links related data points? Probably not. Our brains are great at finding patterns, even where there are none. Most of these personal glitches can be explained by psychology or simple probability. But what about bigger glitches? What about glitches in the physics of the universe itself? Some physicists might point to the weirdness of the quantum world. The double-slit experiment is a classic example. When you fire a particle, like an electron, at a screen with two slits in it, it behaves strangely. If you don't watch which slit it goes through, it acts like a wave and seems to go through both at once. But if you set up a detector to see which slit it goes through, it suddenly acts like a particle and picks one. It's as if the universe knows it's being observed. This is deeply weird. Physicists have complex mathematical explanations for it. But from a simulation perspective, it looks familiar. It looks like a rendering shortcut. A video game doesn't render the details of a room you're not looking at. That would be a waste of processing power. It only renders what the player sees. Maybe the universe does the same thing. A particle's properties aren't definite until they need to be. Until a conscious observer requests the data by measuring it, the system saves resources by leaving things in a state of fuzzy probability. The act of observation forces the simulation to render a result. Then there's the fine-tuning of the universe. The fundamental constants of physics, the strength of gravity, the charge of an electron, the speed of light seem to be perfectly set. If you tweaked any of them, even just a tiny bit, life as we know it wouldn't be possible. Stars wouldn't form. Atoms would fly apart. The universe would be a dead, empty place. Why are the settings so perfect? One answer is that we're just lucky. In an infinite multiverse of different universes, we just happen to live in the one where the numbers were right. But another answer is that they weren't random at all. They were set. They're parameters in the code dialed in by the simulators to make sure the simulation would produce something interesting, like us. Finding these settings wouldn't be a glitch, but it would be evidence of a design. It would be like looking at the source code's config file. So the first step to hacking the simulation is observation. It's science. It's a search for the seams of reality. We're looking for the places where the code is a little sloppy or where the underlying structure shows through. We haven't found a definitive bug yet, but the weirdness of quantum mechanics and the perfect tuning of physical laws are our first clues. They're the strange graphical glitches or the perfectly balanced game mechanics that make a player stop and think, wait a minute, this feels designed. The next level of hacking is more active. It's not just about finding the rules or the glitches. It's about exploiting them. This is what speedrunners do in video games. They don't rewrite the game's code. But they understand the game's physics engine so well that they can make their character do things the designers never intended. They can jump through walls, fly through the air, or skip entire levels. They use the rules against the game. Could we do that with the universe? Maybe we already are in a small way. Einstein's theory of relativity is a good example. It describes the fundamental rules of gravity, space, and time, and it contains some very strange exploits. The theory says that the faster you move, the slower time passes for you relative to someone standing still. This is called time dilation. It's a real measurable effect. GPS satellites have to account for it, or their clocks would become inaccurate. It's not a huge effect in our everyday lives, but if you could build a spaceship that travels close to the speed of light, you could exploit it. You could fly out for what feels like a few years to you, and when you return to Earth, centuries or even millennia would have passed. You would have effectively traveled into the future. That's a powerful exploit built right into the fabric of space-time. Relativity also says that massive objects warp space-time. A black hole is the ultimate example. The gravity is so strong that time slows down dramatically near it. If you could hover near the edge of a black hole without falling in, time would pass much more slowly for you than for the rest of the universe. So, it's another way to manipulate time, using the rules of the system in an extreme way. Quantum mechanics offers even stranger potential exploits. Take quantum entanglement. You can have two particles linked in such a way that their properties are connected no matter how far apart they are. If you measure the spin of one particle, you instantly know the spin of the other, even if it's on the other side of the galaxy. Einstein called it spooky action at a distance. It seems to violate the rule that nothing can travel faster than light. We can't use it to send information faster than light, at least not in any way we currently understand. The outcome of the measurement is still random, but it's a direct, instantaneous connection that seems to exist outside of normal space. It's a backdoor in the physics of the universe. Could we find a way to use that backdoor? Could it be a communication channel or something even more profound? We don't know yet. But it's a clear example of a rule in the system that feels like it could be exploited for something amazing. Or quantum tunneling is another one. A particle can sometimes pass through a solid barrier it shouldn't have the energy to get through. It's like a character in a video game glitching through a wall. It's a low probability event, but it's a fundamental part of how the universe works. It's how the sun generates energy. Could we learn to control this? Could we learn to glitch objects through walls on command? It sounds like magic, but it's based on the real, if bizarre, rules of our reality. This level of hacking isn't about breaking the laws of physics, it's about mastering them. It's about knowing the system so well that you can push it to its limits and make it do things that seem impossible. We're taking the first baby steps. We've built quantum computers that use entanglement and other weird quantum effects to perform calculations. We've built particle accelerators that use relativity to study the building blocks of matter. We are, in a sense, learning to become speedrunners of reality. The third and final level is the one everyone thinks about. Gaining admin access, root privileges, the ability to not just exploit the rules, but to change them. The ability to open up a command console and type give player humanity infinite energy or set gravity 0.5. This is the god tier hack. How would that even be possible? If we're characters in a simulation, we exist entirely within its logic. We're made of the simulation's code. How can a piece of code rewrite the program it's running on? A character in a video game can't just decide to open up the game's C++ source code and start editing. This is the biggest hurdle. To do this, we would need to find a way to interact with the level outside our own. We would need to reach out of the simulation and get our hands on the computer that's running it. There are a few speculative ideas about how this could happen. One idea is that consciousness itself is the key. Maybe our minds are not entirely part of the simulation. Perhaps our consciousness is the player, and our body and the universe are the game it's experiencing. If that's the case, then perhaps through deep introspection, meditation, or other altered states of consciousness, we could somehow access the interface. We could log out, or at least peek behind the curtain. This is an idea that echoes through many spiritual and mystical traditions, the idea that reality is an illusion and that one can awaken from it. Another, more technological path would be to build a machine. We're already building powerful computers. Quantum computers are a whole new level. They tap into the weirdness of the quantum realm to solve problems that are impossible for normal computers. What if we could build a computer so powerful that it starts to strain the resources of the simulation itself? Imagine a video game where you could build a machine inside the game that was so complex. It used up all the host computer's RAM, causing the game to lag or even crash. Maybe we could do something similar by creating immense concentrations of energy or information like a black hole or a super intelligent AI. We might create something that the simulation can't handle properly. We might trigger a system error, and that error message might give us a glimpse of the system underneath. Or perhaps the path is through information. If the universe is a simulation, then everything in it, every particle, every star, every thought is ultimately information. It's data. If we could understand the fundamental language of that data, the base code of reality, we might be able to inject our own code. Maybe we could build a machine that could rearrange Planck scale units of information, directly manipulating the pixels of our universe. We wouldn't be hacking the computer it runs on, but we would be hacking the software from within at its most basic level. This is far beyond our current technology, but it's not strictly impossible under the simulation hypothesis. It would be the ultimate engineering project, but let's say we could. Let's say we figure it out. We find the console. We're about to type in the first command. We need to stop and ask a very important question. Who is on the other side? Who are the simulators? The answer to that question changes everything. The nature of the admins determines the risk of our hack. Think about the possibilities. Maybe the simulators are scientists. They're running our universe as a research project. They could be studying the origins of life, the development of consciousness, or the formation of galaxies. If they're scientists, they might be fascinated by our attempts to hack the system. A simulated life form becoming aware of its nature and trying to communicate would be an incredible result for their experiment. They might even help us, or they might see it as a contamination of their data. A lab mouse that figures out it's in a cage has to be removed from the experiment. They could shut the whole thing down, simulation 147b.x, end process, and that would be it. No fanfare, just nothing. Maybe the simulators are not scientists, maybe they're just kids, or the equivalent of kids in some advanced civilization. Our entire universe, with all its history, pain, and joy, could just be an incredibly detailed video game for them. They're the players. If we start hacking, they might find it amusing. They might see us as interesting non-player characters who have suddenly gone rogue. Or, more likely, they would get annoyed. We're ruining their game. They'd patch the exploit. Or they'd just delete our save file and start over. Getting banned from the universe would be a very bad outcome. There's a more somber possibility. Maybe the simulators are us. The simulation hypothesis proposed by Nick Bostrom suggests that we're likely an ancestor simulation. A future, post-human civilization is running a simulation of its own past to study its history. If that's the case, our creators are our own descendants. They might have ethical rules about not interfering. They might have set the simulation to run and are just watching. If we start hacking, we might be breaking their most important rule, the Prime Directive. They might be forced to intervene to stop us from derailing their historical model. Or, the scariest possibility of all, maybe the simulators are indifferent, or even gone. Maybe they set the simulation in motion and just left it running, like a forgotten program running on an ancient server in a basement somewhere. If we hack it, there's no one to notice, but if we break it, there's no one to fix it. If we accidentally delete the gravity.dl file, reality doesn't just get weird. It stops working, the universe could just crash, a fatal exception, error from which there is no recovery. This brings us to the dangers. The consequences of failure are immense. We're not talking about your computer getting a virus. We're talking about the end of everything we know. One wrong move, one poorly written line of code injected into the fabric of reality, and we could unravel existence. We could corrupt the fundamental laws of physics. We could break causality. We could delete ourselves from the simulation. The attempt itself could be what gets us noticed. Right now, we might be flying under the radar. We're just another civilization evolving on another planet, behaving as the simulation's rules predict. But the moment we start actively trying to poke holes in our reality, we might trip an alarm. An intrusion detection system, the universe's antivirus software. And a program that detects a virus usually does one thing: it quarantines or deletes it. Our first hack might be our last, so maybe we should take a step back. Is it possible we're already hacking it, just in a slower, more methodical way? Think about what science and technology are. At their core, they are the process of understanding the rules of the system and then using that understanding to manipulate the system for our own benefit. That sounds a lot like the definition of hacking we started with. When we discovered the laws of aerodynamics, we couldn't change gravity. But we learned how to build machines that could exploit pressure differentials to overcome it. We learned to fly. That was a hack. When we discovered the structure of DNA, the source code of life itself, we couldn't create life from scratch. But we've now developed tools like CRISPR that allow us to edit that code. We can remove genetic diseases. We can change the properties of organisms. We are hacking life itself. When we build artificial intelligence, we are creating a new kind of mind within the system. We are using the basic rules of physics and computation to bootstrap a form of intelligence that this planet has never seen before. If that AI continues to grow and learn, it could become a far more powerful tool for understanding and manipulating the simulation than our own brains are. An AI could analyze the laws of physics and find exploits we can never dream of. In a way, building a super intelligent AI might be the most effective hacking strategy we have. We're trying to create a user with higher permissions than our own. So perhaps hacking the simulation isn't a single dramatic event. And it's not about finding one cheat code, it's a gradual process. It's the process of civilization. It's the slow, painstaking journey from being passive inhabitants of our world to being active shapers of it. We are slowly but surely learning the admin passwords to our own biology, to our planet, and maybe one day to the fabric of reality itself. This leads to the final, and perhaps most important question. Even if we could, should we? What does it do to us, to our sense of purpose and meaning, if we find out for sure that our reality is a construct? For some, it could be devastating if our lives, our struggles, our loves, and our losses are all just data points in an experiment. Does that make them meaningless? If free will is just an illusion generated by a complex program, what's the point of trying to be a good person? It could lead to a kind of cosmic despair. Nothing is real, so nothing matters. But there's another way to look at it. Does a character in a great novel have a meaningless existence? Is a piece of music less beautiful because it's just vibrations in the air? The meaning we find in our lives is meaning we create. It's real to us. The love we feel is real to us. The pain we feel is real to us. The fact that the stage might be a construct doesn't make the play any less profound. In fact, it could be empowering. If we are in a simulation, then the universe is not a cold, random, meaningless place. It is, in some sense, for us. It was created. It has a purpose, even if that purpose is just the entertainment or research of our creators. And the fact that we, simulated beings, can rise up to the point of questioning our own reality is an incredible achievement. It makes us, in a way, peers to our creators. The drive to understand, to explore, to push the boundaries of what's possible, that is the most human thing there is. The scientific quest to understand the laws of physics is, in itself, the act of trying to read the source code. The technological drive to build new things is the act of trying to write new subroutines. So could we hack the simulation? The answer is maybe. It's a spectrum. We're already hacking it in small ways every time we make a scientific discovery or invent a new technology. We are learning the rules of the game and bending them. Reaching the next level, finding glitches, exploiting the deep physics of the universe seems possible, if incredibly difficult. The final level, gaining true admin access, is so far beyond us that it's almost a philosophical concept. But maybe the goal isn't to find the master password. Maybe the hack is the process itself. The real hack is to be a being that's born into a system of rules, and instead of just blindly following them, asks why. The real hack is to look at the walls of our reality and, instead of just accepting them, to push on them, to see if they give. Whether this is base reality or one of a billion simulations, that quest for knowledge and mastery is what gives our existence meaning. And we're doing it every single day. We keep searching, we keep building, we keep pushing. Not because we want to break the game, but because we want to see just how much is possible within it. That's the real way to win.